Good day, everyone. And once again, your favorite uncle is back. And this time we are looking at, organic reactions. So if you haven't subscribed, please just make sure that you hit that subscribe button. And of course, if you want to get in touch with us, if you need extra lessons, you can arrange them by sending an email to info@mlungisinkosi.co.za. And we are excited. We'll be launching our website very, very soon. So you'll be able to get question papers and everything else that you need from that website. And by the way, please don't forget at the end of the lesson, just hit that like button, and just also just make sure that you, just give super thanks. Hey, that's a monetary contribution. So if you wanna give your uncle some money, all right. So you are more than welcome to do so. Just hit that super thanks and donate any amount that you would like. It would definitely help me towards making sure that I dish out this content. All right, now let's have a look at the question. So they say to us, study the following in complete organic equation for organic reactions, rather, 1 and 2. Now, please just forgive me for, this wobbly question paper that I'm using. I took a photo of it so that I can use it for, doing the content. Right, so now what we've got there is reaction 1. Okay, now we note in reaction 1 we've got a haloalkane, and we are reacting it with sodium hydroxide, but this time concentrated sodium hydroxide. Please, if you haven't watched the lesson, the playlist on organic reactions as yet, please just go and do that. Under our playlist section, just look for organic chemistry and you'll find that lesson there. Now remember, we said if we're going to use a concentrated strong base, okay, with haloalkanes, what we end up with, on the other hand, is an alkene, right? So this will be an elimination reaction. But of course, if we were to use a dilute base, what we would end up with is an alcohol, right? So in this case, we're going to use Zaitsev's rule, by the way. You'll see that Zaitsev's rule simply says, we know we're going to eliminate the bromide, but it's going to be eliminated with another hydrogen. Now, question is it going to be the hydrogen from this carbon here, or is it going to be from that carbon there? Right, so remember Zaitsev's rule says in an elimination reaction, right, we always take the hydrogen from the carbon that has the lesser number of hydrogens. So you see in this particular case, which carbon has lesser hydrogens? It's definitely going to be this carbon over here. So we know this hydrogen goes, and it also goes with that hydrogen bromide. Okay, right. So ultimately what you end up with would be CH3. Okay, you still have that C there with the CH3, but now you've got a double bond. Okay, so that hydrogen is left with the bromide. Okay, and then you've got CH and CH3. Now I want you to please note, now hydrogen with that bromide now has you've got hydrogen bromide. Now, when that hydrogen bromide reacts with the base, in this case, that's an acid-base reaction. What's going to form there is sodium bromide, which is this guy over here. And of course, the rest of it, we're going to have that OH with that H, okay? And of course, it means that you're going to form water as well, okay? Right. And when we look at reaction 2, I'm just analyzing for now, and then we'll answer the questions later. Right, so we've got ethanoic acid, and then reacting with compound Q to form butyl ethanoate. So that's an ester, right? So remember, in this case, you've got butyl ethanoate. Remember, in an ester, we always start naming the alcohol, the alcohol side first. And in this case, of course, this would be the ethanoic acid side, right? So I'm looking at this, it means that this guy comes from this ethanoic acid. That's why it's ether. So that's ethanoic acid, that's ethanoate. So it means that the alcohol that we must have used would have been butane 1-ol, right? Because there it is, it's butyl. So in this case, this should have been butane 1-ol. So we always use a primary alcohol, right? So in the next, so let's answer the question in this case. They say for reaction 1, write down the type of reaction that takes place. It's definitely an elimination reaction. Okay, so we know we're going to form an elimination reaction. And then they say the IUPAC name of compound P. Okay, so that's compound P. So that's going to be carbon number 1, carbon number 2, 3, and 4. So in this case, that becomes 2-methyl. Okay, so that at carbon number 2, we've got a methyl. Okay, and we've got butane or but2. Remember, you always, between the two carbons, you take the one with the smaller number. So this is going to be 2-methyl. Okay, so that's 2-methyl. Please remember that hyphen, okay, between the number and the letter, right? So that's 2-methyl but2. Between carbon number 2 and 3, we take the smaller number. It's but2-ene. All right, I hope that makes sense. Okay, so the next one, they say name of formula of compound T. So you can say that's H2O, or you can just simply state it's water. Okay, right, now let's go for equation for reaction 2. So they say for reaction 2, write down the two reaction conditions needed. So remember, when we're forming an ester, remember we need to use a concentrated sulfuric acid. So we need concentrated sulfuric acid as a catalyst, okay? But we also need heat, okay? So in the presence of mild heat. All right, so the next one, they say the structural formula of compound Q, right? So in this case, we are looking for the formula. We did say it's going to be butane 1-ol. So you can say, well, I know that's going to be 4 carbons, that's but, okay? And in this case, at carbon number 1, we've got our OH, so we can write OH there, okay? Or in this case, you can just write it as OH without the necessarily showing the hyphen between. All right, so in this case, we know that's going to be an alcohol. All right, so now moving to the next question, okay? In fact, let's do this. All right. So they say the cracking of a long chain alcohol, a long chain hydrocarbon. All right, I did apologize for that poor quality. You can see it's kind of skew. All right, but I hope that it's still visible. Right, they say the cracking of a long chain hydrocarbon, which is C10H22, which is in this case decane, right? In a test tube A, in test tube A as shown below. All right, so we are cracking. It means we are breaking down that large molecule into smaller, more usable ones. Okay, so they say 2 straight chain organic compounds are produced in test tube A according to the following organic reaction equation, right? So now what we are going to do is we're going to make sure that we break it into, those 2 organic compounds there. And we don't know what those compounds are, but nonetheless, probably they're going to give us some more clues, right? Now they say to you, state the function of aluminium oxide in the test tube A I am going to make an assumption, honestly speaking. I haven't seen this question before, but I'm going to make an assumption that it acts as a catalyst. Okay. So in this case, it means that it speeds up the rate of that reaction. So in that case, it must mean this is a catalytic cracking. Remember, there are two types of cracking reactions. That is thermal cracking, where we use heat, and there's also catalytic cracking. So I'm assuming it's the latter. Okay, right. So the next question, they say the organic compounds X and Z are now used through bromine water, okay, at room temperature in test tube B. Okay, so they say only compound X reacts with the bromine water. Okay, they say apart from gas bubbles being formed, okay, state another observable change in test tube B. Now, ladies and gents, I want you to please listen carefully. So, in this case, once we know that something reacts with bromine water and it reacts spontaneously, it must mean that whatever it is an alkene. In that case, it's an unsaturated hydrocarbon, right? So in this case, it means that X should be an alkene in that case, right? I am just simply going to assume, well, in this case, it might have been ethene, so that would have been CH2CH2, okay, with a double bond in that case. Now, I'm just wondering, could it be that it was, propene in that case? Of course, whatever, alkene that I take or I assume it is going to affect whatever product Z is, right? And I think they would still, because they did not tell us how many carbons that chain has, right? They did say to us it's straight chains, but they did not say how long those chains are, right? So in this case, I'm going to simply say, well, so what observable change are we going to make? So anytime, remember that bromine water is brown in color, right? So once it reacts with an alkene, it reacts spontaneously. By the way, if you've got an alkane, it would not react unless you put external energy in the form of UV light, right? So in this case, bromine water is usually brown, but once it reacts, it becomes colorless. So you'd say the solution, okay, so the solution moves from brown, okay, from brown to colorless, all right, okay. And then they say to us, write down the type of reaction that takes place in test tube B. Now remember, we're taking an alkene and it reacts with bromine, in this case, to form 1,2 dibromo ethane. So in that case, that must mean that it is an addition reaction. So that is an addition reaction. Okay, right. Remember, we are breaking that double bond and we are forming a single bond. Okay, right. And then they say to us, write down the molecular formula of compound Z. Now, think about it. If we're saying two of those where we've got 2 times C2H4. So remember, we've got 10 carbons and 22 hydrogens in this case, right? So if I say, well, that forms C2H4. Now remember, 2 times 2 would give me 4. So it means what should be compound Z in this case? I've already used 4 carbons. So how many am I left with? I'm left with 6, okay? And I've used 2 times 4 hydrogens. I've used 8 hydrogens. In this case, that's the 2 times the 4. I've used 8 hydrogens, right? So out of the 22, how many do I have? So that's 22 subtract 8. My mind just went blank a little bit. Okay, so that's C6H14. Okay, so they said to you, write down the molecular formula. I would say in this case, it's definitely C6H14. And because it's an alkane, that's why it did not react in that case with bromine. Okay, right. Unless really for you to get an alkane to react with bromine water, you'd have to put external energy in the form of UV light. Okay, right. And then the last question, they say write down the structural formula of compound X. Okay, so in this case, for compound X, I'm going to just write that down there. It looks like that. That's the structural formula of it. Okay, I do hope that makes sense, ladies and gents. I think, look, I stand to be corrected on this. I do think that you could have also assumed others. You could have assumed, well, that's C3H6 in that case, right? In which case, if you did that, if I say, well, that's C3H6, if I have two of those, that will be 2 times 3. That will be 6 hydrogens, in which case you would have now been left with 4 carbons. And then again, if I say, well, this is 2 times 2 times 6 hydrogens, right? It would have been 12. And in this case, if I subtract that from those 22 hydrogens, that you would have been left with 10. So it's possible that you could have said, well, in that case, that would have been C4, C4H10, okay? And in that case, it means that, when you draw or rather when you write the answer for the last compound, so you would have said, well, in that case, that's going to be propene, okay? Or prop 1 in if you want to. There's no other type of propene except prop 1 in. All right, and I think that could have been a possibility. I really, really think you could have done well in obviously either. But yeah, I hope that makes sense, ladies and gents. All right, I just want to leave it here. Please don't forget to hit that subscribe button if you are new, and obviously to just continue to look out for those lessons as I dish them out, just to make sure that you guys benefit. And please tell your parents, all those who are responsible for, paying for your studies. Not that it's a requirement, but it really would be nice if, you would just give support and just give your super thanks, and say thank you to your favorite uncle. Otherwise, I'll see you guys again next time. Sharp, sharp.